In this video, we're going to look at integrating by using a table or a CAS. Right, so CAS is a computer algebra system. We'll start by looking at a couple of examples for looking at a table. So let's jump right in. We will evaluate the square root of 16 minus e to the 2x all over e to the x dx. Now, the thing about an integration table is the form has to be identical to what's on the table. So let us first make the substitution u is equal to e to the x, then du would be e to the x dx, meaning that dx is du over u. Using the substitution, our antiderivative becomes the antiderivative of the square root of 16 minus u squared over u. Then replace dx with du over u. So what we have is the antiderivative of the square root of 16 minus u squared all over u squared du. Right, now, if we look at our integration table here, right, we see we start with some basic integrals. Right, so these are basically the integrals that were derived in a typical Calc 1 course. Then we have trigonometric integrals. Well, our integral does not involve trig functions, so let's keep scrolling. Exponential logarithmic. Originally we had exponential, right, but it didn't fit any of these forms, which is why we used u sub. Hyperbolic, we're going to skip. Inverse trigonometric, where we didn't involve inverse trigonometrics. Involving a squared plus u squared. Well, it wasn't a squared plus u squared. Involving u squared minus a squared. Well, it wasn't that either. A squared minus u squared. It was that. And if you look at number 88, that is the form we have. Our a squared was 16, meaning our a is 4. So we're going to use formula number 88. Let's see if I can highlight it for you. It doesn't look like, oh, there we go. All right, so that's what we're going to be using. All right, so via formula 88, we get negative 1 over u times the square root of 16 minus u squared minus the inverse sign of u over 4 plus our constant of integration. Now just replace u. We'll get negative 1 over e to the x, square root of 16 minus e to the 2x, minus the inverse sign of e to the x over 4 plus our constant. Next, let's take a look at antiderivative 6x times tangent squared of x squared. If we make a substitution, u equals x squared, we'll get that du is 2x dx, right? And so what our antiderivative becomes now is 3 times the antiderivative tangent squared of u du. Now let's go and take a look at our table. So this is a trig function. Excuse me. So we're going to come up here, trigonometric integrals. We're looking for tangent squared of u. There it is. That's formula number 20. So by formula 20, this is 3 times tangent of u minus u plus our constant. Right, replacing u, we get 3 times the tangent of x squared minus 3x squared plus our constant. Now, obviously, using a computer algebra system is the quickest way of evaluating an integral. So let's take a look at the antiderivative of dx over the square root of x squared minus 4. Right, and let's see what our CAS will give us. Right, so we come over. Right, so we're going to go to Menu, Calculus. We want an integral. Now, since we're not doing a definite integral, we want to leave that field blank and that field blank. Now we just type in our function. And it was 1 divided by the square root of x squared minus 4. Now, we have to tell the calculator, the CAS, with respect to what variable? X. Hit enter. And we get the natural log of the square root of x squared minus 4 plus x. Now, this is not going to give us plus our constant of integration, so we're going to have to add that in manually. And finally, let's use a CAS to evaluate the antiderivative of sine cubed. Let's come back over to our CAS. Right, another way we can do it on here is instead of going to the menu, we can just type in integral. Right, and then it's the same procedure, right? So we want our function. So we want sine of x cubed, now comma, and with respect to what? X. Hit enter, and there we go. So cosine of x times negative sine squared x over 3 minus 2/3, and then don't forget our constant of integration.